Okay, in this video I'm going to continue on with exercise 4B of the book Fundamental Applied Mathematics. We're on page 105/106 and the question is 21. By the way, this question is starred, so this is an honours question. So the question reads, a ship A is travelling southeast at 20 kilometers an hour. Ship B is travelling at 50 kilometers an hour in a direction 40 degrees north of east. Draw a diagram to show the velocity of A relative to B and find its magnitude and its direction corrected in nearest degree. And we're finally asked, by how much would B decrease its speed without changing direction so that A would appear to be travelling due south. So I suppose, where do we begin with this? The same place we always do, by drawing our y-axis and our x-axis. That makes our xy plane or our Cartesian plane. And then we draw the vectors which you know. So we know ship A is travelling southeast at 20 kilometers an hour. So I'm just going to draw it like this. It's going southeast. Alright, and this is 20 kilometers an hour, so this is VA, whose magnitude is equal to 20. And we know its direction is southeast, so this means this is 45 degrees. And then I'm going to resolve this vector straight out. So we need the two vectors which, when added together, create it. So it's going to be parallel to the y-axis, parallel to the x-axis, in those directions like that. That's going to be a right angle. This is going to be VA sub x I hat, and this is going to be VA sub y j hat. This is going to be equal to 20 times the sine of 45, because cos of 45, or the sine of 45, and this is going to be 20 times the cos of 45. And the sine and cos of 45 are 1 over root 2, so it's going to be 20 over root 2 for both. So just one sec there now. So it's going to be 14.14. I'm just going to say, I'm going to call it 10 root 2. So basically what we're saying is the velocity vector VA is equal to 10 root 2 I plus 10 root 2 j. Now in actual fact, if you look at the direction, it's going in the negative j direction, so this is actually a negative sign here. Alright, so I'm just going to redraw that then. Let's redraw that. Alright, so let's draw the plane very quickly. Draw this vector here is 10 root 2 I hat. This vector here is equal to 10 root 2 j hat. Alright, so the next thing we need to do is get the velocity vector of ship B. Now we're told that ship B is doing 40 degrees north of east. So it's going in this direction here. This is 40 degrees. This is VB, whose magnitude is equal to, what is its magnitude? 50 kilometers an hour. So it's 50 here. So if we resolve this in the same fashion, we're going to get the two vectors which, when added together, will create it. They must be parallel to the axes, of course. And we're going to get, this is going to be 50 times the cos of 40 I hat. And this is going to be 50 times the sine of 40 j hat. So we'll find that VB is equal to, so 50 times the cos of 40 gives us 38.3, so I'll say a 38 I hat. And then we have 50 times the sine of 40, and that's 32.1, so we'll say plus 32 j hat. Alright, and then separately we have the velocity vector of VA is equal to 10 root 2 I plus, or negative 10 root 2 j. Alright, so we have the velocity vectors VA and VB. So the next thing we're asked to get is the velocity of A relative to B. Alright, so let's just get rid of the velocity vector VAB, which we don't need anymore because we've resolved it. Alright, so VAB is equal to mathematically VA minus VB, so that's very straightforward. However, of course, it means crucially that B is in a frame of reference whereby B believes that it is stationary. Okay, now it's not actually stationary, but it is in a frame of reference such that it can analyze everything as if it was stationary. Alright, so let's just find out what VAB is very quickly. So you get VAB And I'll just, I won't do this rigorously. So we're adding the unit vector VAB, so it's VA minus VB. So it's going to be 10 root 2 minus 38 I hat, and it's going to be negative minus, so it's going to be, we'll take this as a minus here, it's going to be 10 root 2 plus 32 j hat, like so. Let's just plug those into the calculator. So we have 10 root 2, and we've got to take away from that 38, and this is going to be negative 23 I hat. Well, actually it's going to be negative 23.8, so I'm going to say negative 24 I hat, and we have 10 root 2 plus 32, and this is going to be 46.1, so I'll say 46, so negative 46 j hat. That's going to be the velocity vector VAB. Alright, so I'm just going to rub out the bits that we don't need anymore. So it has to find its magnitude, so we need to get the magnitude of this vector. So just to sketch the vector, it's negative, negative, so it's going in this direction here. Alright, without drawing the actual plane itself. I'm going to resolve it. I'm going to resolve it this way. So that's in the I hat direction, that's in the j hat. They're at right angles, and the vectors go in these directions here, like so. This is the angle theta. This vector here is VAB sub y, and it's in the j hat direction, and this is VAB sub x, and it's in the I hat direction. So this one, of course, is going to be 24, and this one is going to be 46. And oh, it's negative, negative. I drew it in the wrong direction. Geez, that's a very silly thing to do. Let me do that again. Sorry about that now. Sorry, it's negative, negative, so it's going this direction. And just to resolve it, once again, we go parallel to the x, parallel to the y, in these directions, like so. They're right angles. This is VAB sub x I hat, and this is VAB sub y j hat. This is going to be equal to 24, and this one's going to be equal to 46. They're not negative 24 and negative 46 because the negative signs just give you our direction. And if I call this angle here theta, then in order to get theta, we just take an inverse tangent. So I press shift tan for inverse tan. It's going to be 46 divided by 24, and give me an angle of, we'll say, 62.4 degrees. So theta is equal to 62.4. Alright, so that's its magnitude, or that's its direction. Then to get the magnitude, it's just a right triangle. So I want to get the length of the side in green, the hypotenuse. So that's going to be very straightforward. It's going to be the square root of negative 24 squared plus negative 46 to be squared. Alright, so let's just plug that into the calculator. So we have 24 to be squared plus 46 to be squared. We square root that answer. We get 51.8, so I'm going to say this is 52 units. Alright, so that was very quick. Now just one second, I check the answer in the back of the book on 4B question 21. 52 is correct, and 62 degrees is correct as well. Alright, so the next part of the question is as follows. We're asked to find out by how much would the speed of B have to be decreased without changing direction so that A would appear to be travelling due south. So basically what we can say here is this is just starting the question again with a slightly different scenario. So get rid of all this. We don't need any of that anymore. So we're changing B, okay, and this was equal to B here, and we're not changing its direction. Alright, we're not changing its direction. So what we can do is change this vector. I'm just going to call it B cos 40, and I'm going to call this vector here to be B sin 40. Alright? Now we're told that we want it to appear that A would appear to be travelling to B to be travelling due south. So we want B to be stationary. So we want VAB. Okay. Now why do we want VAB? Just bear with me. I know my reading is a bit poor. So VAB is VA minus VB, but it means that B is considered to be stationary. So it looks like A is moving. So we need to alter the velocity of B so that A would appear to be travelling due south. Okay, so this is definitely the one we want here. We don't want VBA because in that case A would be in the stationary frame of reference. So that's not what we want. But what we want here is that VAB appears to be going due south. Okay, and if it's going due south, which I'm going to draw in black, that means it's got no no I hat component. So that's very straightforward. So I'm going to call it, it's going to be, we'll say 0 I hat plus x j hat. That's equal to VA, which is equal to, VA was equal to 10 root 2 I negative 10 root 2 j. We've got to take away from that VB, which is B cos 40 I hat, and it's going to be plus B cos, or excuse me, B sine 40 j. Alright, now we're getting a bit cramped here. So let's just do our addition. We know that the x component is going to be equal to 0. So we know if we add 10 root 2 and we take away from that b cos 40, we know that this is going to be equal to 0. Therefore b cos 40 is equal to 10 root 2, and we know that b is equal to 10 root 2 over the cos of 40. I'm just going to work that out there in my calculator. So you have 10 root 2 divided by the cosine of 40, working out at 18.46. So I'll say 18.5. So you know now what the magnitude of the vector b is. Alright, so that's what b is equal to. B is equal to 18.5. So let's just get rid of what we don't need. We don't need this anymore. And we're told, of course, that all the I components go to 0, so just get rid of those. Alright. This was a negative, wasn't it? It was. And what we're going to get is that x j hat is equal to negative 10 root 2, and this is going to be negative b sine of 40. But we know what b is because it's 18.5 times the sine of 40, negative 10 root 2. So let's just work out what that is. So it's 18.5 multiplied by the sine of 40. We add to that 10 root 2, and we know that the magnitude is going to be 26. So x is going to be negative 26 j hat. So we know that VAB is equal to 0 I hat negative 26 j hat. And does that make sense? Yes, it does. It means it's definitely going due south, and it's going due south by a magnitude of 26. Alright, but we are actually asked to find by how much we have to slow down b. So let's just answer the question with which we were given, or which was posed. So we said that initially b, the magnitude of b initially, and this is given on page 105, was equal to 50. And we reduced the magnitude of b, we'll say let's call this b2 and this b1, to 18.5. Alright, to 18.5. So all we got to do then, of course, is just subtract one from the other in order to actually give the answer which is required in the back of the book. So we're going to get 31.5 units. Alright, so let's just have a look at that at the back of the book. 4B question 21. Yeah, and 31.5 kilometers an hour is correct. Alright, so thanks for watching. Please pass it on to your friends and subscribe to my channel.